In the previous calculations, I have shown you the use of the graphical method in solving for the resultant vector, or particularly the resultant force. Take note that force is a vector quantity. Okay, so this video will contain the use of your component method in solving for the resultant forces of a vector quantity. Component method. So from the word itself, from style component method, it involves the breaking of forces into its x and y component, or its f and x component. So when you talk about a component method, so let's say I have a force in my in my y and x plane. So let's say this is a force of 5 Newton, 30 degrees. Take note that your 5 Newton at 30 degrees can be broken down into its x and y component, or the horizontal and vertical force, which is particularly if the arrow is going up, so we can break it down into f of y and your f of x. How? By using the law of your so, ka, to, a. Take note that so means sine theta. Sine theta. Take note that your theta is the angle that is attached to your x-axis. This is your theta or phi. Okay? So, if the angle is attached to your y-axis, it is up to you on how you will solve this one. If you will just subtract it into 90 degrees, or you will go on with the calculations without confusing yourself. Okay? So, take note that your sine theta is equal to the opposite, fy, all over your hypotenuse of your the resultant force, or the resultant of this x and y component, or the force, divided by f. So therefore, my fy, or the y component of my 5 Newton, is equal to 5 f sine theta, considering that my f is equal to 5 Newton and my theta is equal to 30 degrees. So therefore, my y component of 5 Newton is equal to 5 sine theta. So calculating for the value of your 5 sine 30, 5 sine 30, so we'll have a value equal to 5 halves, 2.5. And the value of its y component, or your fy, is fx is equal to k fx. K is equal to cosine theta, cosine theta, which is equal to fx all over the hypotenuse, or the resultant force, which is equal to fx is equal to f cosine theta, which is equal to 5 cosine 30. Therefore, 5 cosine 30 is equal to 4.33. This is the x component of this force, x and y component of this force. So take note that if there are many forces, like let's say 10 newtons, 6 newtons, 3 newtons, you can solve the resultant force of these forces using this component method, by breaking each of the forces into its equivalent x and y component, directing it to the direction of your force. So another thing to remember in your component method is that if the arrow is going up at your first quadrant, so at first quadrant, therefore it is projected that your fx is positive, your fy is positive. Okay? But if your arrow is going in to the second quadrant, it is projected that your fx, take note that this is your theta, theta, theta. Your thetas will always be positive. Okay? Thetas will always be positive, whether it is at the bottom or at the top. Always take note that the sign configuration will base on the direction of your forces. So if it is at this second quadrant, it is projected that if your arrow is going up, so therefore you have your positive y, fy, but negative fx. And then if you are at this third quadrant wherein you have both negative fx and negative fy, of course, in your fourth quadrant wherein you have positive fx and negative fy. Okay? This will be the sign configuration when you are dealing with your component method. And all the angles are always positive. Okay? So, solving for our last example using this component method, let's say that we have our 6 kilonewton at 60 degrees. So, 6 kilonewton at 60 degrees. This is your 6 kilonewton at angle 60 degrees with the horizontal. And then we have 45 degrees for your 2 kilonewton. 45 degrees for the 2 kilonewton using your component method. So if we would use our component method in solving for this one, be careful of your configurations, especially in the signs of your f of x and your f of y's. Okay, so let's do it. We have your 45 degrees. So as I have said, let us break down your components or your forces into its own component. So first, the component of your 2 kilonewton. Okay, so this is 45 degrees. So let's have our f of x and your f of y. And then let's have your f1, which is equal to 2 kilonewton. For beginners, it is better to have a table. Okay, in order for you to not confuse yourself, in order to have more practice. Pero pag sanay na kayo, therefore, kahit na f of summation of f of x na lang, and then i-project nyo na lang siya. So, f of 1, so we have our force, the breakdown of your forces. So, this is the arrow for your f of x. It is going to the right, which means that it is a positive force. So, you have positive 2. So, this is your theta, katoa, opposite. Since you are going to solve for the f of x, you will use ka. So ka. So cosine adjacent divided by hypotenuse. Okay? So we have 2 cosine theta or your 45 degrees. Okay? 2 cosine 45 degrees. That is positive, right? So 2 cosine 45 degrees. And then for your fy, take note that your fy, you are projecting your fy going down. Therefore, it is negative sign. Pag going down, you will use your opposite over hypotenuse. So this is your opposite. So negative going down 2 sine 45. 2 sine 45. Okay? And then your F2. Your F2 which is equal to 6 kilonewton. Okay, 6 kilonewton. 6 kilonewton. So take note that the projection of forces. So going down at x component, it is going to the left. Okay, going to the left. So therefore we have negative. It is going to the left. Negative 6 cosine 60 degrees, and then at the y component it is going down, so therefore it is also negative 6 sine 60. So getting the summation of f of x and the summation of f of y, so therefore we will add this one. We will add the value of your 2 cosine 45. So 2 cosine 45 plus 2 negative 6 cosine 60. So this is equal to 2 cosine 45 minus 6 cosine 60. You have the value of your summation of f of x is equal to negative 3 plus square root of 2 kilonewton. Negative 3 plus square root of 2 kilonewton. Or it is equal to, approximately equal to negative 1.5857 kilonewton. Okay. For the summation of f of y, we have negative 2 sine 45 minus 6 sine 60 will have a value equal to negative 2 sine 45 minus 6 sine 60. You must be aware, or you must have your calculator when you are watching this video, in order for you to understand more about the calculation. So negative 3 square root of 3 minus square root of 2, which is equal to negative 6.61. That is your summation of f of y. Okay? So next is we will solve for your f of r. Solving for f of r. Solving for f of r. Solving for our resultant force f of r. So we'll have your f of r is equal to the square root of the summation of your f of x squared plus the summation of your f of y squared, which is equal to the square root of 1.587 squared. So negative yan, magiging positive pa rin yan kasi nga squared. So plus, so lagyan na lang ng negative para hindi kayo malito. Negative 6.61 squared. So we'll have a value equal to the square root of negative 1.5857 squared plus negative 6.61 squared. Take that it is in kilonewton. So we'll have a value equal to 6.797 kilonewton, which is approximately equal to our graphical method. And then for the value of your theta is equal to tan inverse summation of f of y all over summation of f of x. So why? So basically, by adding the components of each forces, you are creating the components of your f of r. So take note that your summation of f of x is going here, which is basically your negative 1.5857 kilonewton, and then your summation of f of y, which is basically equal to negative 6.61. Okay, so projecting these two forces, so we'll have a value equal to, using your parallelogram method, yan, by the principle of your parallelogram method. So this is your 6.61. So it is on the tip, or the toe to the tip of the arrow. Then you will project this one as your FR. Okay, as your FR. Okay, so let's say that this will be your theta. So shift tangent negative your summation of f of y, which is equal to 6.61, negative 6.61. So tangent theta, this will be your theta. So opposite over adjacent. So we have your opposite, which is equal to tan raised to negative 1. The opposite of theta is equal to negative 6.61 divided by 1.587. So take note of the coordinate is both negative. So you have shift tan negative 6.61 divided by negative 1.587. So you'll have a value equal to theta is equal to 76.499 degrees. This is the theta when you are projecting it to the counterclockwise direction of x-axis. So counterclockwise yan. But if you would want, if the problem would ask you to project it into its clockwise from the x-axis, therefore we will get the angle from our positive x-axis in the clockwise direction to your resultant force Fr. So therefore take note that this angle, or the straight angle, the value of a straight angle is equal to 180 degrees. So I may say that this will be my theta r, or the angle, or phi r, or the angle of your resultant force respecting that corresponding to the clockwise direction. So we have our phi r is equal to 180 minus theta. Knowing that your theta is equal to 76.499, so therefore I may say that it is 180 minus 76.499. So we have a value equal to minus 180. So we have 103.5 below the x-axis. Take note that this below the x-axis indicates the direction of your theta, that is your 103.5 is below the negative x-axis, which means it is at negative 103 degrees. Okay? Next method that I would want to show you is using our calculator method. So using our calculator method, we would directly input the value of this angle, okay, considering that it is your negative angles and then your positive angles. So let's say that you will use our calculator method. Calculator method. Calculator method. Take note that your calculator method can only be used if you will directly get the value of your resultant force. Okay? It is better for you to master the component method and the parallelogram method, especially in the problems wherein you would need to maximize or minimize the forces that you would use. Okay? So using your calculator method, so let us project the value of forces using its polar coordinate. When you talk about your polar coordinate, is that it is your coordinate in the x and y system. So using your calculator method, you will have your f of r, f of r is equal to, you will have a angle equal to 2 kilonewton. Since it is below the x-axis, therefore we will project this as negative 45 degrees. Fr, so 2 kilonewton, angle of negative 45 degrees plus 6 kilonewton, angle of, so take note that this is equal to 180 degrees. 180 degrees to. So therefore we will have 180 minus 60. So we have angle of negative 120 kilonewton. So how did we get this 120? From negative 180 degrees minus negative 60 degrees. So we will have a value equal to negative 120 degrees. Okay? So that is our FR. How will we solve it using your calculator? Directly input it into your calculator. So I will have my calculator here. So this is a calculator like your 991ES. Okay? So using this calculator, your calculator, so we'll input the value of your 2 kilonewton. Take note that your calculation should be in decimal or in deg. It is in rad, so I will change it into deg. So you may use your 991ES. So 2 shift angle. So since there is no angle, let us change the mode. So your calculator should be in radian. Okay? So should be in complex. So option, okay, wait lang. Shift 2. Your calculator should be in complex. So there. Pag ginagamit niyo is 991ES, so shift mode lang kayo. Mode and then press 2. Mode 2 pag nasa 991ES kayo or calculator. So you would choose your complex and then 2 shift angle, 2 shift angle. Your angle is negative 45 degrees. Negative 45 degrees. Okay, you can see that there, you can see the x and y component of the 2 angle of negative 45 degrees plus your 6 shift angle negative 120 degrees. Okay, you will see that you will have a value equal to, so this is negative 120 degrees. So this is the value of your resultant force in its x and y component. Compare it to the previous calculations, or in your component method. You can see that they are similar. You have your negative 1.58 and negative 6.61. This is the value of your x component, and this is the value of your summation of y component. So how will you turn that one into its vector, into its polar form? So you will just press shift, and then press your complex, and then into your calculator, shift 2 lang yan, and then press 3, because may makikita kayo doon na r angle theta. So this one, r angle theta. Okay, let's delete this one. So I will have an open and close parenthesis. Okay, we're in. I would use the answer is equal to 1.5. I will just first store it. Shift store at A. Okay. Okay. AC. So i-input ko lang ulit. 2 shift angle of negative 45 degrees plus 6 shift angle of negative 120 degrees. So this is the x and y component. So close and open parenthesis, and then shift 2 into its equivalent polar form. So this, in this calculator, or in your calculator, you can check if your resultant force is correct. Take note that this negative here indicate that it is below the x-axis at a clockwise direction. Okay, so I hope you enjoyed this one. Okay, so thank you and good day.